Good afternoon, students. We were working the last time on the double angle formulas for sine, cosine, and tangent. In class, I showed you how you can come up with each one of these formulas by using the general formulas for sum and for sum of sine and cosine and tangent. Sine of alpha plus beta, cosine of alpha plus beta, tangent of alpha plus beta. That's the last thing I showed you in class. Plus we did. So we said that sine of 2 theta equals to 2 sine theta cosine theta. For cosine of 2 theta, we came up with cosine squared theta minus sine squared theta. And for tangent of 2 theta, we came up with 2 tangent of theta over 1 minus tangent square of theta. Now, let's work with the last formula for the following problem. The last problem we did in class was example 1. So now we are going to start with example 2. So right here, the formula for tangent of theta, the double angle for tangent, it tells you this. Let me change the font size. So it tells you that anytime you have tangent of 2 theta, that is going to be equivalent to 2 tangent of theta over 1 minus tangent square of theta. So right here you see that theta is 15 degrees, right? So that's what it shows you here. If we look compared to the formula, that's exactly what we see. So that means that tangent of 2 theta, since theta is 15 degrees, that expression that we have there is the same thing as tangent of 2 times 15 degrees, right? Because that's the value of theta. So if we want to find the value of that expression, tangent of 2 times theta, which is 2 times 15, will be the same thing as tangent of 30 degrees, right? And then if we want to find the value of tangent of 30 degrees, we're going to go to a triangle of a 30, 60, 90 triangle. So we have a triangle here, and my angle of reference is on the first quadrant. My angle of reference is 30 degrees. So the opposite to 30 is 1, adjacent is the square root of 3, and the hypotenuse is 2. So if I want to find tangent, tangent will be y divided by x, right? Which is those values. So it would be y divided by x, which in this case is 1 divided by the square root of 3. But then you have to rationalize it, right? So if I rationalize that, that is going to give me 1 over square root of 3. I multiply the numerator and denominator by the square root of 3 to rationalize it. That is going to be square root of 3 over 3. And that is the answer for this expression. So that means that tangent of 2 theta in this problem is going to be square root of 3 over 3. Make sure that Monday, once you look at all these problems, if you got any question, you can ask me on any question on any of these problems that I went over in these videos. Next thing that we're going to work on, I'm going to show you some other extensions of the formula for double angle for cosine. If you recall, for the general formula that I gave you for the double angle of cosine was cosine of 2 theta equals cosine squared theta minus sine squared theta. Now we can do some modifications of this formula, and so that you understand what these modifications are, I'm going to show them to you here. For example, for cosine of 2 theta, since it is cosine squared theta minus sine squared theta, one of the modifications that I can do, we already know from a Pythagorean identity what cosine square of theta is. Cosine square of theta is the same thing as 1 minus sine square of theta, right? If you solve for cosine in the identity cosine square plus sine square equals 1, cosine square is going to be the same as 1 minus sine square, right? And then of course minus sine square of theta, you can combine like terms, you can see right here. So that's going to give you 1 minus, this is negative 1 sine square minus 1 sine square is going to be negative 2 sine square of theta. By combining those like terms, that's what we got, and that's the formula that we see down here. That's a modification of the original formula. By using the Pythagorean identity, we can come up with that. Also, we can do the same thing in the other hand. Cosine of 2 theta, we can also rewrite it as, instead of cosine square of theta minus sine square of theta, we already know what sine square of theta equals to. Sine square of theta is the same as 1 minus cosine square of theta using the Pythagorean identity. So if we use that, then look at what is that going to give us. So that means that cosine of 2 theta equals cosine square of theta, then distribute the negative, that's -1, and then negative times negative is plus cosine square of theta. And if we combine like terms, 1 cosine square of theta plus another cosine square of theta, that's the same as 2 cosine square of theta minus 1. And that is the second modification that we see right here. Okay, so they are just modifications of the formula, of the original formula, which is cosine square minus sine square for the double angle for cosine. It's just different ways of writing it. Okay, so what we are going to work on the next question, verifying the identity. This is one of the problems that I told you. Usually what we're trying to do, or what we need to attempt to do, is rewrite the most difficult side, or work with the most difficult side and try to rewrite it into the easiest side, right? In this case, this is the exception to the rule. It is not going to work, because as you can see, the only strategy that we can use here to solve, to work on the most difficult side would be that we can try to factor the cosine of theta from both of these terms right here. But if I factor it, we're still going to be left with 4 cosine square of theta minus 3. And then again, we get stuck right here, because what we want to make this equal to cosine of 3 theta. How can we simplify to that? In this case, the formulas that we are given right now is the formulas for the double angle, but we don't have a formula for cosine square other than 1 minus sine square so far. So right here, this doesn't work. So what we need to do then is we're gonna have to work with the easiest side in this problem. That would be the way that we can work this out. Okay, so the easiest side, what can we do here? Cosine of 3 theta. You already know that you can use the sum or difference of angles to rewrite that cosine of 3 theta into a different expression. We can rewrite it as cosine of theta plus 2 theta, right? That will be the same thing as 3 theta. And if you look at your formula, the formula for cosine of alpha plus beta, I'm going to write it on the top. Cosine of alpha plus beta is the same thing as cosine of alpha times cosine of beta, then the sign changes, minus sine of alpha times sine of beta. And do you see that you have a subtraction right here on this problem? So that is the key. So we can rewrite this. Alpha is theta and beta is 2 theta, right? So that would be the same thing as, let's rewrite it, cosine of theta, which is my alpha, times cosine of beta, which is my 2 theta, minus sine of alpha, which is my theta right there, times sine of beta, which is my 2 theta right here. Then, using the formulas that you already know, let's use the formulas to change. Now we want the formula to have only cosine, right? You see that right here? So what is the formula for cosine of 2 theta, a double angle for cosine that we can use? I'm going to put them right here, that has only and only cosine in it. If you look at it, it is this one in the middle, right? So I can use that formula to rewrite that cosine of 2 theta using only cosines, you see? So that cosine of 2 theta, we can rewrite it into 2 cosine of theta, 2 cosine square of theta minus 1, right? Minus, and then also, you also have an identity that we can use for sine of 2 theta that I showed you first. And the identity, let me go back to it so you can see it. Sine of 2 theta right here is equal to 2 sine of theta times cosine of theta, right? So that is the identity that we can use for this one. So sine of 2 theta, we're going to rewrite it as 2 sine of theta times cosine of theta. Simplify this. If I distribute the cosine of theta to these two, what do we get? 2 cosine squared times cosine will be cosine cubed of theta. And you see that we have a cosine cube of theta right here. Minus cosine of theta times 1 will be cosine of theta. Then, if you distribute it to the one on the right side, sine of theta times 2 sine of theta would be 2 sine square of theta, right? And I'm going to bring the cosine of theta down here. What else can we do? Remember that the expression on the right side has only cosines. So what can I do, or what formula can I use to rewrite this sine square into just cosine? We have a formula for that. Remember that sine square, if we modify the original sine square plus cosine square equals 1, sine square is equal to 1 minus cosine square, right? So I can rewrite the sine square into this using the Pythagorean identity. So that new expression would be 1 minus cosine square of theta, and then we're going to rewrite the rest, which is 1 minus cosine square of theta times the cosine of theta here in the front times the 2, and then we write the rest, 2 cosine cube of theta minus cosine of theta minus 2 times 1 minus cosine square of theta times cosine of theta. Okay, so let's finish simplifying this. What are we going to get then? 2 cosine cube of theta minus cosine of theta. Multiply the 2 and the cosine of theta to these two, distribute them to these parentheses. So 2 times 1 is 2 times cosine of theta is negative 2 cosine of theta, right? Then negative 2 times negative cosine square of theta is positive 2 cosine square of theta times cosine of theta is positive 2 cosine cube of theta. Cosine squared times cosine will give you cosine cube. What else can you do? Do you see? You can combine the like terms. This one and this one. 2 cosine cube of theta plus 2 cosine cube of theta would be 4 cosine cube of theta. And you can also combine negative cosine theta minus 2 cosine. This is negative 1 cosine theta minus 2 cosine theta would be negative 3 cosine of theta. And now that checks, because if you look at the right side of the equation, the right side tells you that that has to equal to 4 cosine cube of theta minus 3 cosine of theta. And that checks. This is how we can verify this identity. Okay, there's a lot of things involved, and it is a long one, so it's probably the most difficult one that I have in these notes. Check on anything that we did in here, and if you got any questions, just let me know in class. Next. Now, these are called power reducing. These are some of the strategies that you use in calculus, basically when you're doing integrals. And this is helping you to, this helps you to basically reduce high powers of sine and cosine into linear powers. Okay? And basically those formulas come from here. Look at these formulas that we originally had, the ones that we came up with right now. For example, if I look at this formula right here, and I solve for cosine square, we're gonna come up with this formula right here. So that is cosine of 2 theta equals, so all of these formulas are modifications of the original formula, so they have a sequence. So if I solve for cosine square of theta right here, I need to move the 1 over, so you're gonna get cosine of 2 theta plus 1 equals to 2 cosine square of theta, and then to get rid of the 2 I divide by 2, and that is what we see right there. So to reduce the power of a cosine square, we rewrite it into a linear power by using this formula right here, which is what you see on this side. Cosine of 2 theta plus 1, or 1 plus cosine of 2 theta divided by 2. Likewise, if you solve for sine of square of theta, then you're going to get a formula that will tell you how you can reduce the power of sine to a linear power using cosine, of course. The formula tells you. Now you can do the same thing. If you leave the sine square of theta by itself, you're going to end up with, like when you solve for sine square of theta, you're going to end up with this formula right here, which is 1 minus cosine of 2 theta divided by 2. So you move the 1 over, then divide by negative 2, and that should give you exactly what you see right there, which is 1 minus cosine of 2 theta divided by 2. These are called power reducing formulas, and they help you to reduce high powers of sine and cosine, and also tangent, into linear powers. Okay. There's also a formula for tangent square. By solving for the tangent square, you can also come up with this formula right here. Okay. Alright, so let's go ahead and utilize these formulas, and what we are going to do, I want you to write an equivalent expression for cosine to the 4th power of x that does not contain any power. So in other words, that has linear powers. Okay. So the first thing that we know of is that cosine to the 4th of x, the formula that we have is for cosine square, right? So what you need to do first is that you need to rewrite it as cosine square of x times cosine square of x, or cosine square of x squared, whichever way is best for you. So if you want to separate it like this, it's completely okay. And now the formula for cosine square of x for power reducing, let me bring it over here. This is the formula that we're going to use to reduce the power of the cosine. Okay, so cosine square of x is equal to 1 plus cosine of 2x divided by 2 according to the formula, right? So we're going to rewrite this as 1 plus cosine of 2x divided by 2 times, and then there's another cosine square which also changes to 1 plus cosine of 2x divided by 2. So cosine to the 4 of x is going to be equal to, then simplify that. You can multiply, FOIL the numerator, right, and distribute the denominators. The denominator is going to give me a 4, and if I distribute the numerator, you're going to get 1. 1 times 1 is 1, right? So I'm going to do it by pieces so you can see. 1 times 1 is 1. 1 times cosine of 2x is going to be plus cosine of 2x. Then right here you get cosine of 2x times 1. It's another cosine of 2x. And then cosine of 2x times cosine of 2x is cosine square of 2x. Then divided by 4, I'm going to separate it into several fractions. Okay, so it's going to be 1/4 plus 1/4. Well, or before that, let's combine like terms and then I separate it. Okay, I forgot that I can combine like terms, which is these two right here. These two are like terms. 1 cosine of 2x, this one has a coefficient of 1, right? 1 cosine of 2x plus 1 cosine of 2x is going to be 2 cosine of 2x. And then I bring the 1 to the front, plus cosine square of 2x. I'm going to separate it into several fractions, okay? The divided by 4. So that is going to give us cosine of 4x. Well, cosine of to the 4th of x is going to be equal to 1/4. I'm going to divide the 1 by 4. Then the next one, 2 divided by 4 gives me 1/2, right? So this 2 divided by this 4 is 1/2 cosine of 2x plus, and this is a 1 in the front, right? So that's going to be a 1/4 cosine square of 2x. Now the question to you is, have I reduced the powers to linear powers completely? And that will be a no, because we still have a cosine square at the end. So what do? We're going to apply the same formula Okay, we're using this formula right here. So we're going to get the following. Cosine to the fourth of x is going to be equal to 1/4 plus 1/2 cosine of 2x plus 1/4 times, and this is going to become, remember my denominator is 2, right, for this formula? But be very careful, because originally we're talking about an angle that is theta. And right here on the formula, when you rewrite it, it's going to be 2 theta. But on this one, my original angle, you see that it is a 2x, right? So on the formula, it's basically going to be 2 times theta, but theta is 2x. So that is going to give you a 4x, right, on this expression right here. So you're going to get 1 plus cosine of 4x divided by 2. And then if you multiply by the 1/4, what do you get? Let's separate it right there. So that's going to be 1/4 plus 1/2 cosine of 2x plus, you multiply this one by 4, is going to be 1/8 times 1 plus cosine of 4x, and if you distribute the 1/8, you are going to get 1/4 plus 1/2 cosine of 2x plus, distribute the 1/8 here, 1/8 plus 1/8 times cosine of 4x. And the only thing I can do to finalize this problem, I can combine the 1/4 and the 1/8 using the common denominator. So I multiply this one by 2, right? So it will be 2/8 plus 1/8 is 3/8, right? So my final answer for this is 3/8 plus 1/2 cosine of 2x plus 1/8 cosine of 4x. And as you can see, we power reduced the cosine to the fourth of x into an expression with only linear cosines. Okay, all the way. And this is how the formula works. That's all you have to do. Make sure that you reduce it so that the power of the cosine or the sine becomes a power of 1. That's called power reducing. Okay? If anywhere on this problem you have any questions this next Monday, just let me know. Now, these are called half-angle formulas. You remember the formula that we had? Let me write them down, the formulas on the previous slide. For the power reducing, we got these 3 formulas, right? Oops, it went too far. I want you to look at those 3 original formulas. And what happens, for example, on the first formula for sine squared of theta? If I want to get rid of the square, what do I need to do to get rid of this square right here? I need to take the square root on both sides, and it's going to be a plus or minus in the front, right? That is called the square root property, right? So that cancels out the squares, and that's what you see right here. But also, since this is a half angle formula, if I divide the angle by 2 right here, then I divide the angle by 2 right here, and that gives me a theta as the angle inside. And that is called the half angle formula. That's where it comes from. Okay? It comes from the power reducing formula, but solving for the sine and getting half of the angle, that's the formula that we obtained. Okay? Right here. Same thing for the cosine square. If I want to get rid of the square, I have to get the square root on both sides, and for the square root, it's always a plus or a minus. And then we get half of the angle by dividing the angle by 2, and right here this cancels out, so it is cosine of alpha or theta, whatever it is. And that's the formula that you see right here. Last formula for tangent is likewise, you do the same thing. If you want to solve for tangent, you get the square root on both sides, and that gives you a plus or a minus. Okay, and then to get the half angle formula, I'm going to divide the angle by 2, that's half, and I divide the angles by 2 also here. That cancels out the 2, so you get theta and theta on this one, which in this case they use the letter alpha to denote the angle. So to get these are the formulas for half angles. Okay, so I'm going to copy down the formula so we can see them on the next slide, because we're gonna use them. But that's where they come from. Okay, let's go ahead and find the exact value of this expression for cosine of 112 divided by 5. So you need to double this angle, because and again, there are several strategies. Remember that one of the strategies was that you can try to write this angle as a sum or difference of two special angles, right? That was one of the ways. But in this case, I cannot subtract or add two special angles that will equal to a decimal angle, right? And that was one of the strategies that we could use to find the exact value without having to use the calculator. But again, in this case, the sum or difference by adding two angles or subtracting two angles that will equal to 112.5, but being a special angles, 30, 45, or 60, there is no such thing. Now, one of the things that we can do, we can rewrite this angle as a half angle. What does that mean? I can probably find an angle, because in order for me to make that decimal into a whole number, since it is a 0.5, if I double it, then I can write it as a half angle. So if you double this angle, you're gonna get multiply times 2, that gives you 225. So that means that the angle 112 is the same thing as 225 divided by 2. So it is a half angle. Okay, so you double it to find what number divided by 2 will equal to that, right? And you see that that turns it into a special angle, because the angle of 225, it is basically an angle in quadrant number 3. I was gonna say number 2, but it's in quadrant number 3. Just follow me, and if you draw that angle in quadrant number 3, what is the angle of reference? Because you know from here to here is 180, right? This right here is 180. So to get to 225, my angle of reference is supposed to be right here, 45, right? 180 plus 45 is going to be 225. So that is going to be a 1, 1, and square root of 2. That is a 45, 45, 90 triangle, right? So, but the value, since it is on quadrant 3, both the x and the y are negatives, right? So, let's go ahead and find the value of this expression. So, using the formula, this is your alpha. That 225 is your alpha. So, we're using this formula in the middle. Okay? Cosine of alpha divided by 2 equals to, wait a minute. On this one, we need to decide. Usually, the formula, it is a plus or minus for the half angle, but because of the square root. But knowing cosine, what is the sign for cosine in quadrant number 3? Since it is x divided by r, look at this, x divided by r, so it is going to be negative, right? So on my expression, I am supposed to have a negative. Understood? It's going to be negative square root of 1 plus, then we need to find cosine of alpha, which is cosine of 225 degrees divided by 2. Okay, so that cosine of 112.5, which is that 225 over 2, right, is the same thing, equals to negative square root of. Now let's go ahead and find the value of cosine of that angle to 225, which is this triangle in quadrant 3. So cosine will be x divided by r, which is 1 divided by the square root of 2, right? So the cosine of that 225, if I find it there, it will be negative 1 divided by the square root of 2, which if I rationalize it, is negative square root of 2 over 2. Just multiply the square root of 2 on the numerator and denominator. This is what we get, right? So that would be 1 plus negative square root of 2 over 2, right? So I'm going to write it so you can see what's going to happen, because there's a lot of fixing that we need to do to this problem, because we need to put them under the same denominator right here. So that's going to be a minus, right? Square root of 2 over 2, and then over 2 right here. So I need to put them with the same denominator. So I need to multiply the 1 by 2 on the numerator and denominator, right? So we can have it as the same denominator. So my new expression is going to be, let's continue, cosine of 112.5, which is my 225 over 2, equals to negative square root of, that becomes a 2 minus the square root of 2 divided by 2, right? And then over 2. That the first 2 comes from here, and the other one comes from the other denominator, right? And if I do the sandwich theorem, remember this is over 1, right? You multiply these 2 and these 2, and you get an answer of negative square root of 2 minus the square root of 2 times 1 stays the same, over 2 times 2 gives you a 4. Is there anything else I can do to simplify this? The numerator, no, but the denominator, yes. Because if you do this, you separate it into 2 square roots. The square root of 4 is going to give you a 2. So my final answer would be this. Cosine of 112.5 as an exact answer is going to be negative square root of 2 minus square root of 2 over square root of 4, which is equal to 2. That is the exact answer for this expression. Okay. So once again, revise this problem, and I made sure that I drew everything as possible. If you have any questions in class, you let me know. Next problem. Verify the identity. So we need to verify this identity, so I'm trying to make sure that this is equal to tangent of theta. Okay? Using the formulas for cosine of 2 theta and sine of 2 theta. Let me bring them over here to this slide. Cosine of 2 theta and sine of 2 theta, which is the original formulas. Well, sine of 2 theta, that one is simple to remember. Is 2 sine theta cosine theta, but still I'm going to copy these formulas for you. And also the 3 formulas for cosine of 2 theta that we have, which is these 3 right here. And I'm going to erase some things so we can have some, I can copy them down. These are the different formulas that we need, right? This one and these other ones. Alright, so let's move on with this problem. So, using these formulas, we need to verify the identity. So, remember that the procedure, with the exception of one of the problems that we just did, is work with the most difficult side and make it look like the easiest side, right? So, just use whatever properties that you know of so we can turn this back into these double angles, we can make them into single angles, because my tangent right here is not a double angle. It is just theta, right? Not 2 theta. So we need to get rid of those 2 thetas in this expression. That is basically your key. So the first thing to do is cosine of 2 theta. Try either of these expressions. Now you see that there is no squares in this one. So I don't know if you would like to try to write them using the 2 cosine squared theta minus 1, 1 minus 2 sine squared theta, or the cosine squared theta minus sine squared theta. Let's try whichever one, and I will tell you that either one you use is gonna give you an answer. You will come up with the answer no matter which one you use. Okay? So let's pick one. I am going to pick, let's say, the middle one. Okay? So cosine of 2 theta is the same thing as 2 cosine square of theta minus 1 over. Now let's do the same thing for the sine of 2 theta. Sine of 2 theta, the formula is right here, is the same as 2 cosine theta, 2 sine theta, cosine theta. Doesn't matter which one is first. 2 sine theta, cosine theta. Let's continue simplifying this, and we need to make it be equal to tangent of theta. So distribute the negative up here. So that's going to give you 1 minus 2 cosine square of theta. Negative times a negative 1 is positive 1, right? So over 2 sine of theta times cosine of theta. Then, what else can we do? Look at it very carefully. Look at the numerator. Combine like terms, right? That is going to be a 2 minus 2 cosine square of theta over 2 sine theta cosine theta. Now, there is another special property here for what we did before that we can apply on the techniques of proving an identity. And that technique will come from what we just did on the numerator. Look, factor. You see that we have a GCF of 2, so we can factor out a 2 from there, so we're going to be left with 1 minus cosine square of theta. But wait a minute, we also know something else. 1 minus cosine square of theta, according to the Pythagorean identity, we did it already right now. What is that equals to? Sine square of theta, right? So that parenthesis is basically going to become this right here. 1 minus cosine square equals to sine square of theta. Sine square plus cosine square equals 1. If you solve for sine square, it gives you 1 minus cosine square over 2 sine of theta times cosine of theta. Then everything took shape, right? So now what can you do? Cancel out the 2's, and on the numerator you got 2 sine of thetas, right? Because it's sine square of theta, that means sine of theta times sine of theta. So I can cancel one of these sine of thetas with the bottom sine of theta, and that gives you a result of sine of theta, only one of them, over cosine of theta. But sine divided by cosine is the same as tangent of theta, and the other side of the identity set equal to tangent of theta, right? So if we go up, that's what it is on the left side. So it checks. And like I told you, if you would have used also this, substituted the cosine of 2 theta with this one, you are still going to get the answer. Even if you substitute the cosine of 2 theta with this one also, you should still get the answer. Now, on some way, probably one of the three is going to be shorter than the other two, but the answer is still going to come up. And as far as I remember, I think the one that will make it shorter will be the third one. If you try it yourselves, instead of substituting the cosine of 2 theta with the middle one, try it with the last one and see if, like I said, it is shorter, in fact. Okay? Next, these are some additional formulas that you have in your formula chart for the definitions for half angle of tangent. These are some modifications of the formula. Okay, and that's modifications of this formula that we have right here. So those are going to be these ones that you see right here. Tangent of theta divided by 2 equals to also 1 minus cosine of theta over sine of theta, and tangent of theta over 2 can also be expressed as sine of theta over 1 plus cosine theta. Those are two other ways of rewriting this formula. Let's verify this identity using this. This is a very simple identity. Now, we can see basically that the most difficult side, you might think that the most difficult side is the right side, which in this case it's not. Because whenever you have a half angle, that is probably going to be the most difficult side, even though it is short. Because the half angle complicates anytime you have a modification of the angle, double angle, triple angle, half angle, that would probably be your key, that you need to work on that side so you can get rid of that half angle, double angle, or whatever, triple angle, whatever is it that you have. Okay, so let's use one of those two formulas. You can use whichever one you want. However, based on one of the properties, you see that we don't have a fraction, and this one gives you fractions. So one of the techniques about the fraction is separating. If you turn it into the second one, you cannot separate it because there's only one term on the numerator. Okay, but if you use the first one right here, this one, I can separate the numerator by dividing both of them by sine of alpha. So I think that will be the most recommended one to use here, so you can make a separation and see if we can turn it into what is shown here. So tangent of alpha divided by 2, according to the formula, is 1 minus cosine of alpha over sine of alpha. If you separate it into two fractions, you're going to get 1 over sine of alpha minus cosine of alpha over sine of alpha. And then what do we know about that? 1 over sine is the same thing as cosecant, and cosine over sine is the same thing as cotangent, and we are done. Because that is equal to cosecant of alpha minus cotangent of alpha, which is what we have on the other side. Checks. Now, this is not the only way of doing it. I'm just giving you an option. Okay? The other way of solving this problem, you can also use the other formula, but it will be a little bit longer. I didn't want to mention it, but I will, just to give you the other side of it. You could have also used the bottom one, which is sine of alpha over 1 plus cosine of alpha. You can still do it. Sine of alpha over 1 plus cosine of alpha. But there's another strategy that I show you. You see that right here we have the denominator of a sum, but on the other side we have a minus, and it's on the numerator. So one of the strategies that I show you is that whenever on one side you have on the other side something similar but with the opposite sign, then you have to multiply by the conjugate. The conjugate of this would be 1 minus cosine of alpha, but you have to do it also to the numerator. 1 minus cosine of alpha. If you do that, the numerator is going to become sine of alpha minus sine of alpha cosine of alpha. Or you know what? I am going to leave it factor because some things are going to cancel out at the end. Okay, I'm going to leave it factor instead. So the denominator, if you multiply it, you're going to get 1 minus cosine of alpha plus cosine of alpha, if you FOIL it, minus cosine square of alpha. And the negative cosine of alpha, positive cosine of alpha cancels. So you end up with sine of alpha times 1 minus cosine of alpha over 1 minus cosine square of alpha. But wait a minute, once again we ended up with another definition. 1 minus cosine of alpha is the same thing as sine square of alpha. So that is going to give you sine of alpha times 1 minus cosine of alpha over sine square of alpha. What can we do? We can cancel out this sign with one of these signs on the bottom, and we are left with 1 minus cosine of alpha divided by 1 sine of alpha. And then you go back to this, which you can separate it into two fractions. You see that right here we ended up with this right here. Then from here it follows that you separate it into two fractions and you end up with this again. Even whichever one you use is still going to give you the same thing, but of course you look at the left side, it was way more complicated than what we did on the right side. Okay? And this is a summary of all the formulas for this section 5.3. If you have any question, don't forget, you can ask me on Monday. Have a great night and weekend as well.